Right, guys. So I've got a microphone, I've got a screen. That's 2 out of 2 of us tech works for, so I feel sorry for Chris because there's bound to be a failure at some point here. A bit like Russian roulette. So I'm Rick. I work at Ngineered. Yay! As you can see from the Twitter tag there, please follow us. So I'm going to talk about Kubernetes and Google Compute Engine. Our job is to help people migrate from data centers into various cloud vendors, Google being one of them. So I'm going to give you a little bit of a demo to show you what it's all about. Now, rather helpfully, last night about 8 o'clock, Google took this out of beta and into general availability. So all the commands changed overnight. So I had to rewrite things very hastily this morning. So let's pray it all works. So what is GKE? It's Google Container Engine. Now, you might be saying, why K? Well, I'm going to say they're probably stealing that from Kubernetes a little bit, but GCE was already taken. That's Google Compute Engine. So unless they stuck a 2 on the end, it was going to start sounding a little bit AWS-like. So they probably decided against that. So what you get with Google Container Engine is a pre-configured image. It's actually Debian underneath. It's already got Kubernetes installed on it, and it's incredibly easy to launch an entire cluster. One thing it does lack is resizing that cluster after. But if anyone's ever tried to set up a huge core OS with Kubernetes on, it can become incredibly complex to look after bits and pieces and make sure all your scripts are in the right place. With GKE, it's literally a one command line to launch it, which hopefully will work in a moment. I've included a link there, so if anybody wants to go and have a bit more of a read about it, google.cloud.com/container-engine, and you'll get more information. Kubernetes is for kind of orchestration and grouping very similar containers together. When Kubernetes talks about resources, they call them pods. When they talk about collections of similar resources, they call them replication clusters. So we're going to try and spin a few of those up today. Now, I've also included a link here, which if you go to, you'll get all my notes and all the commands that I'm going to run tonight, so you can have a play with this yourself. Like any cloud provider, Google give you so much free to play about with. I think you get $300 worth of credit, so you shouldn't incur a bill if you go and have a play with this. So I'm going to keep the demo short, because the longer a demo is, the more likely it is to fail. Right, let's switch over here. So I don't know if any of you have ever seen this. I'll try and zoom in a bit. So this is basically the console here for Google Cloud, and I'm going to start off by just hopping on a box I've pre-configured and cheated and set up that's got all my SDK tools on there. Another caveat here is that I've also added a little rule into the default firewall rules that allows any web traffic into my network, so port 80, port 443. By default, if you try this, it just doesn't work. So let's get going. Right, okay, someone's fainted with that revelation at the back there. Right, so G-Cloud is a tool set. It's very much like, if anyone's familiar with AWS, which is kind of the biggest one, it's a bit like using the AWS CLI, gives you access into things. So up until yesterday, you had to put beta in all of these commands, but what we're going to try and do here is launch a cluster. We're going to call it demo cluster. I'm cribbing off my notes here drastically. And I'm going to say I want 4 nodes in this cluster. Now, if you was to do, oh, that's not good. Did you mean clusters? Yes, I did. So if you try to do this by hand, you've got to spin up 4 boxes. You've got to then go in and configure one as master, or have some metadata in there at the beginning when you boot up to automatically configure that. So there's a lot of manual work that this one command is taking out of everything. So what's happening now is just sitting there and creating our demo cluster. If I flick back quickly to the web console, there's container engine down here, and as you can see, our demo cluster is now spinning up, and I'm going to have 4 nodes come up in that. Let's see if this updates. So currently I'm only showing 1 server, but if you actually refresh this console, sometimes it's nice to you. And I'll show you, you've actually got 4 brand new servers running in GKE, but they're all pre-configured and managed for you, he says. There you go. And they're all labeled GKE demo cluster. So all handled by our container cluster here. When it finally comes up. So one of the nice things this, the G-Cloud does that you don't get when you just spin something up from the interface is it automatically configures Kubernetes and kubectl for you. Otherwise, you have to run a series of commands to pull down credentials and SSL certs, CAs and stuff like that, and get a working config. They've started trying to wrap it up into this get server config command at the bottom here, and it sometimes works. But if you've done this by hand as well before, you know that setting Kubernetes up is relatively easy. As soon as you want to do the security levels on it, it gets slightly more complicated than a lot of the documentation goes into on GitHub. So we just twiddle our thumbs a little bit while this spins up. Always takes a little while. But what I'm going to do, I'm going to go through. Here we go. So we now have our cluster up, and one of the first commands you can run to check everything's working is kubectl version. And what this should return to you is your local version of Kubernetes, which is 1.0.3, and the server version. The fact that we're returning the server version is really good news. It means kubectl is configured, has all the authentication to talk to our cluster, and we didn't have to do anything apart from run one command line. So it's taken a lot of work out of this for us. So here with kubectl now, we're going to actually spin something up and run it. So I'm going to do something nice and simple, and I'm going to spin up a couple of Nginx boxes, 2 in fact, and I'm just going to use a stock image Nginx, and I'm also going to give this a port 80. So unlike Docker on its own, when you spin up a machine with Kubernetes, each container gets its own IP address, and that becomes very useful because it means that you can assign port 80 to all the same containers that are mapped. In fact, you can have several services all running on port 80 and then use IPs to address them if you really wanted to. So you don't have to worry about that 5000 port 80 style mapping you do with Docker run commands. So that command there actually gave us 2 Nginx servers, and they would have booted very, very quickly. And one way to show them is kubectl again, get pods, and I'm just going to give it a wide format just so we get a little bit more information returned. So from here, hopefully you can see we've got 2 Nginx servers running. It's assigned a random string to the end of it so we can differentiate between the 2 of them, and both up and running. It's also telling us what node those instances are running on. And if you went into the web console, you can actually track that down to a physical box and work out. But one of the nice things it does is actually make sure they don't both run on the same physical host, because you end up with a single point of failure. Once you've got this replication cluster, the nice bit you've got here is that you can't go down between 2 Nginx nodes. So if we're going to run a command and we're going to physically stop a box, so we're going to stop a pod, and in this case I'm going to stop the second one, which is Nginx MBHZ6. So I'm going to kill that box off, and the fact it just returns pods and the name indicates it's done something correct. So now if I run this command to get the number of Nginx servers we've still got 2 running. But if you notice from the top return, and the next return there is that we've still got two nodes, but the bottom one is called a different name, and it's on the same host, kind of by luck, but it could have swapped host. So a replication cluster will basically help you maintain the amount of containers around. And as you can see, it's only been running 11 seconds. So it helps with a little bit of auto healing. As boxes die, containers get replaced. So what else can we do? Can we actually see if it's working? Well, one of the quick ways, I say quick ways, it's an awful command. So we're going to rely on curl here, and we're going to cheat a little bit. So there's a Kubernetes command you can use, and it's kubectl again, and we can get specific information from a pod. In this case, I want to get an IP address of a particular container, so I can curl it and make sure it's actually returning some HTML for me. So kubectl get pods, Nginx, let's choose our original one, FOT68, -o. Yeah, like I say, yeah, quick command. Template. Bear with me, guys. Dot status. Dot pod IP. If I'd have been sensible, I'd have put this in my command history already. Really want to. So running this, I get a little bit of HTML come back, and those of you who've seen this before, this is just basically the Nginx holding page. But it just proves our instance is up and running, it's on port 80, and it's there. And if I swapped the name of the pod out for the second instance, I'd get the same thing returned. So that's great, but it's all internal at the moment. It's all on its own subnet. It exists in a world that the rest of the people out there on the internet cannot see. So Kubernetes has a great little addition where it can control load balancers. And this isn't just linked into Google Compute and Google Container Engine. With modules, you can actually control AWS ELBs. There are modules floating out there on GitHub that will let you control hardware load balancers as well. So this command becomes quite flexible. So here we go with kubectl again. And I'm going to expose, not myself, luckily. You can breathe a sigh of relief, Sean. And I'm going to create external load balancer equals true. So what this is hopefully going to do is within here, within our web console again, we have load balancing, and it's going to create us a network load balancer. And this is now starting to spin up. It takes a little while to come, but a good way to check that if it's live and if it's there and working is to use kubectl get services, and we call ours Nginx just because I was being lazy. Now, when you first run this, you only get one IP, and yet again, it's an internal IP. So that's internal to your network in Amazon times, like your VPC IP range. If you run this a few times, talk among yourselves while I do this, we'll eventually get an external IP address. Here we go. And that external IP address is what we'd stick our DNS pointing to. If we go to our browser, with any luck, he says, and it disappears. I told you, I've gone on too long in the demo now. We're now at that point of failure. There we go. Welcome to Nginx. And that's our load balancer connected through to Kubernetes with
if you did it really quick and didn't faff about like I did in between 3 commands, and you've got a web cluster up and running. So it's really quite a cool product to use. I've been playing around with cloud for quite a lot of years now, too many I like to think about. And this product, when it came out in beta, was one that I looked at, and it was one of like the cool buzz ones again. It felt like early days of Amazon Web Services, and it was quite fun to play with. So definitely recommend you go home, get a free account, have a play with it. It won't cost you a penny as long as you don't leave it running for 3 years, and see what you can do with it. So any questions, guys?
Nothing's perfect. What's missing?
Resizing of the cluster. That's the big one. So Kubernetes itself lets you resize that replication group that I spun up. So I could add another couple of Nginx containers if I wanted to. So I could take use of my 4 nodes that I've spun up. But if I wanted to add another VM underneath, there's no way to do that at the moment. That may have changed last night with the whole plethora of other changes, but who knows? It should be coming.
Microphone. More questions? Someone was asking on Twitter, why not Mesos?
So why not Mesos? I think mainly because Kubernetes kind of came from Google ran an internal product called Borg, and as Google famously say, everything runs in a container in Google. Whether that's true or not, I'm not sure. And they thought, Borg's quite a cool idea, let's release it to the public. Looked at it, and as with any system you develop internally, you think, actually, this is really, really Google-centric. Myself and Sean's done things before and looked at it and gone, no, this is Ticketmaster-centric. And it doesn't fit the rest of the world. So they decided to rewrite. Kubernetes was born and opened up to the world. Personally, I think it's a little bit of a masterstroke by Google, because I can run Kubernetes in my data center. I can run it in Amazon. I can run it in Rackspace. It all of a sudden opens up from that default mentality that a lot of people have of, let's use AWS. All of a sudden, I can use any cloud, and I can migrate between clouds as well. One of the next implementations of Kubernetes is called Kubernetes, and that should actually let you control cross-cloud environments. So why not Mesos? Google had a plan somewhere, is the answer.
Another question? Yes?
No, that's it.
Thank you very much.
Thanks.